welcome to Operating Systems, Chapter 12 on IO systems, right? There are two main jobs of a computer and IO and computing, right? In many cases, the main job uh, is IO and the computing or processing is merely incidental. For instance, when we browse a web page or edit a file, our immediate interest is to read or enter some information, not to compute and answer. Right? The role of the operating systems in computer I/O is to manage and control I/O operations and I/O devices. Although related topics appear in other chapters, here we bring together the pieces to paint a complete picture of uh, I/O. First, we describe some basics of I/O hardware because the nature of the hardware interface places constraint on the internal facilities of the operating systems. Right. Um, Next, we wanna talk about the I/O services provided by the operating systems and the embodiment of these services in the application I/O. Right. Then we will be explore how the operating system bridges the gap between the hardware interface and the application interface. Uh, so, at least for this chapter, we're concentrating on the first uh, issue and probably skip some of the uh, other issues. Basically, we want to introduce the basic I/O hardware and discuss the I/O services provided by the operating systems. Right? So the control of devices connected to the computer is a major concern of operating system designers today because I/O devices vary so widely in their function and speed. For example, we have mouse, hard disk, flash drive, and tape drive. So then there must be method to control them. These methods from the these methods basically form the I/O subsystems of the kernel, right, of the operating system kernel. Okay, I/O devices technology exhibits two conflicting trends. On one hand, we see an increasing standardization of software and hardware interfaces. This trend basically helps us improve devices, right? On the other hand, we see an increasing broad variety of I/O devices. Some new devices are so unlike previous devices that it is a challenge to incorporate them into the operating system. Right? So, we have device driver present in uniform device access, to access the system and whatnot. Right? All right. So let's continue some of this. And so, right. So in I/O hardware, right? In I/O hardware, uh, again there are a variety. Um, um, there are an incredible variety of I/O devices, and we're talking about this, from these tapes transmission. We're talking about device networks, Bluetooth, Wi-Fi. We're talking about human interface devices, screen, keyboard, mouse, right? Uh, so so there are a lot of basically devices and how it communicates, right? A device communicates with the computer system by sending a signal over a cable or even through the air, right? It's depending on the medium of channel that you're using. The device communicate via the machine via a connection point we call a port, right? For example, a serial port, right? Uh, the a device. So that's one connection. But if the devices share a common set of wires, the connection is called a bus. A bus is a bus is you know some on your computer we have something like the PCI bus used in most computers today. It's a set of wires and rigidly defined protocol that specifies a set of messages that can be sent on the wires, right? So you would be familiar with your graphic card requiring a certain type of support for bus, right? So based on this support, then you can specific specification is set and on what devices can be connected to the bus, right? So these standards define basically the timing, the voltage, and etc. of how the device can communicate with the bus, right? When a device when a particular device, say device A has a cable that plugs into device B, and device B has a cable that plugs into device C, and a device C has a plugs connected to another device, right? uh, on the computer. This arrangement is basically called a daisy chain. A daisy chain is usually operates in the similar to a bus, right? Buses are used a lot today. A typical bus structure appears on most of your computer systems, right? Which are using the PCIe bus, right? Which we're gonna see a picture here, right? So there's a PCIe bus here that connects all of your uh, uh, devices, right? So other than the board and the bus that uses daisy chain, right? Uh, you know, there are also things that are connected to the bus called serial attached SCSI, right? Or SAS for short. Right? They are bus plugged into a SAS controller, right? A SCSI controller. Now PCIe is a flexible bus that sends data over one or more particular lanes. So you can imagine it like a information highway, right? Each lane is therefore composed of many wires, about 4 wires, right? And can handle data in a full duplex. I mean, you can it's data is moving in and out, left and right in such steps. And so they may contain a few lanes by itself, right? On that side, right? So okay. In some cases, in most cases, there is a controller, right? Which is a collection of electronics that can operate a port, a bus, or a device, right? A serial port controller is simply a device controller to connect your serial interfaces. Usually it's a single chip or in the computer that controls the signal of the wires of the serial port, right? In contrast, there are also other types of port connections. We call a fiber channel bus controller, right, which is not that simple because it handles fiber communication, right? Okay. Okay. So that is one of those things, right? So all of this we say are connected and they have direct IO instructions, right? All right, so on okay, so we'll stop here for a bit and we'll continue and talking about memory map IO in a bit. So let's take a little break and we'll continue in the next video presentation.